project. The next project, we will go over to SRF Limited and hear about packaging film and then quality-driven sustainability initiative. So, very welcome to the next project.
Good day, respected jury. I am Pawan Saxena from SRF Limited, India, and I'm going to start the presentation on our project to reduce carbon emissions in SEZ Unit by 5% for the base year 22-23, along with my team members Parikshit, Pawan and Nawaz. And we have adopted a 8-step methodology of SRF, and time frame for this project is between April and September 23. Talking about the need for this project, this comes from the global focus on sustainability, and our project idea was to reduce carbon emissions in our plant by 5%. If we see the pie of our emissions in our plant, 54% comes from electricity consumption, 44% comes from petcoke, which is a fuel for heating, and other elements contribute a minor portion of this pie. Breaking it down further into the electricity, we have studied and we found that loads are fixed. We can't reduce it further in our plant, and that's why we dropped it. And coming to the petcoke consumption, we found there are a lot of areas to improve here. As you can see in this table, there is a distribution matrix for each area. And if we talk about the requirements, to understand the requirements, on the quality front, we had to maintain the temperature 330 plus minus 2 degrees Celsius, and there should have not been any increase in the cost. And as far as delivery is concerned, there should have not been any adverse impact on process efficiencies and uptime. And of course, this entire project must be remained non-hazardous, easy to use, easy to operate and maintain. Exploring fuel types, as you can see in this table, based on the calorific value and their cost and emissions. The challenges what we had is to switch to greener fuels with the lower emission rate. That means it would increase the operational cost, and also it will ask for additional capex. So our goal was to reduce carbon emissions with the existing facility in the plant without adding any additional capex, and timeline was 6 months by various steps like solution identification, piloting and full-scale implementation. From now onwards, Nawaz will take it forward. Thank you.
As we mentioned in previous slide, to explore the alternatives, we have studied all our 3 plants with all possible alternatives. There were 3 alternative possibilities. The first one is reduce heat load. The second one is improve efficiency of heater. Of course, the third one is reduce wastage. Next, coming to the reduce heat load, first alternatives. In resin plant, it's not possible, even though we have high requirement of heat in resin plant, but due to process parameter constraint, the heat reduction not possible in this area. For film plant 1 and 2, in TDO, we can reduction the heat by working on stretching ratio. Other were not possible in this area. Next, coming to the second alternatives, improve efficiency of heater. Here we did industrial benchmark, which is 82%, where we are at 76%. Next, coming to the reduce heat, reduce wastage. It is common activity, so it is applicable for all 3 areas. During the Gemba visit, it was observed that there is a significant amount of unburned fuel accumulated and settling on the top of the nozzle. So we modified the nozzle from flat surface to the curved surface. Before the modification, we conduct FMEA to avoid unexpected failure and variation process. So next, coming to the key modification. The key modification, the first key modification is machine welding replaced with the casting. This has benefited as no breakage of welded joint. The second key modification is number of hole increased from 4 to 5. This benefited as velocity increase, improved fluidization and better combustion. The third key modification is reuse of spent ash, which is having high calorific value, 7,000 kilocalorie per kg. This usable till 1,500 kilocalorie per kg. This has benefited as reduction in fuel consumption.
So further in step 4, while finding the detailed solutions, we have established some processes for reducing the heat load in cast lines. So this is our process flow for the film manufacturing process. So mainly we are using heat load in two areas. One is TDO and second one is the MDO. So we have listed some alternatives for reducing the heat load in MDO and TDO areas. The first alternative is we can reduce the hot oil temperatures. So the effect of this this solution is increase in number of film breaks, and it will also deteriorate the film properties. So we have dropped these alternatives. The second alternative is we can eliminate the heat losses in the system, and the potential effect is we will have some reduced heat losses. So countermeasure we have established is we have to arrest leakages and improve the insulations. The third one, which is the larger one, we can reduce the frequency of hot air blowers in TDO, but it will impact on our film shrinkage properties that can be adjusted by adjusting the TDO spindle widths. So first I will explain the process of TDO and the TDO spindles. So this is the orientation diagram for TDO. TDO is basically a hot oven, where the different zones are placed at different temperatures. We are feeding the film at 2.5 meter width, which is further stretched up to the 9 meter of width. So here we have applied the TRIS methodology, in which we can either increase or decrease the width of the TDO spindles. If we increase the width of spindles, the mechanical strength of film getting good and the thermal stability getting poor. On other hand, if we decrease the width of the spindles, then thermal stability gets better and the mechanical strength gets poor. So our improving feature here is the tensile strength, which is the corresponding TRIS feature is strength, and our worsening feature is shrinkage, and the corresponding TRIS feature is the stability. So if we apply the contradiction principle of TRIS, so three principles can be used in our system, and in our process only one principle is applicable, which is the 15 dynamics, in which we have to optimize the relaxation pattern of film by adjusting the spindle widths and the frequency of blowers. So in step 5 we have come up with the implementation plan. So initially we have planned the step-by-step reduction of frequency of TDO blowers. So on first trial we have reduced the frequency from 50 Hz to 47 Hz, and the spindle width increased from 9150 mm to 9175 mm. In second step we have reduced the further frequency from 47 to 45 Hz, and the spindle width is increased from 9175 to 9200 mm. So in both the cases the film properties are not impacted. And so in next step we have further reduced the frequency from 45 to 44 Hz, and the spindle are kept at 9200 mm, which is the maximum possible limit. But in this case the film property is getting deteriorated, so we have stopped at the step 2 and we have fixed, and our final countermeasure came up with the that we have to run the blower at 45 Hz and we have to keep the spindle width at 9200 mm.
Now talking about the verification of results, first coming to the heater efficiency, our heater efficiency has improved from 76% earlier to 82%. 1.5% improvement has come by nozzle design modification, and 2.8% improvement has come by the change in the stretching pattern in the TDO. Now talking about the film characteristic, there has been the most important characteristic that we thought would get impacted is the TD shrinkage. There has been no impact in that, and this is the only film property impacted by heat reduction. All other get better by heat reduction. Coming to the verification of result with the larger goal, our average carbon emission comparing financial year 22-23 versus 24-25, it has come down by 25.4%, and again comparing similarly with the petcoke consumption, it has also come down to the same tune of 25.4%, with an average annualized saving of 46.3 million. Transferring to daily management, we created some new standards and some were revised, like furnace nozzle design were updated altogether with the parts catalog, ash handling SOP and the feeding SOP were created new, control mechanism and monitoring standards were revised. Now coming to reflection as an overall impact, our project impacts the UN Sustainability Goal 12, that is responsible consumption and production. The changes in the relaxation pattern and reuse of ash were a new learning for us. This project helped us to defer a potential capex of 30 million INR, which we had taken for increasing the heater capacity. We also partnered with supplier, that is the modified nozzles were developed by a local vendor by upgrading his knowledge and the technology. This has been a breakthrough project in strengthening SRF PFB's capability development in our continued sustainability journey as a responsible manufacturer and contributing to the overall goal of a sustainable nation. Thank you.
Thank you very much for the project and the presentation. And I'm looking at my jury members here if there are any questions. Anybody raising his or her hand in this case? If not immediately, Somaya, well, I'll ask my question first, Somaya. I'll come to you in a second. You mentioned as a quality characteristic the TD shrinkage, and you had a graph of that shrinkage on. I was wondering if there were any capability figures, because this seems like a quality characteristic that could be put into a capability calculation to see, you know, before the changes and after the changes, what the impact on capability was. But maybe you have the numbers and they're not shown.
Billy, okay. So talking about capability, we checked our process using the control chart. The stability was seen. Capability study was done for this, but yeah, we did not share that the capability for the process is over 1.33.
Okay, thank you. Somaya, come to you now first.
Thank you. So thank you so much for the presentation. You already asked my question. I only have a comment to add on this, and this is about the SDG goals. I believe that your project outcome also contributes to goal 13, which is climate actions because of the reduction in the CO2 emission level too. So this is just a comment.
Thank you.
Thank you.
Mr.
Thank you.
Narahari?
Over from electric heating to oil heating, is it correct?
So yes, some parts of the process wherever we had electric heating first, we switched them to oil heating because after the improvement in the efficiencies, we got some spare load available. So some part of it we shifted.
So how about oil contamination in the process?
So the oil is in closed loop. So it's a heat exchanger. One side we blow the air, and in the secondary loop there is hot oil, sir. So there is no direct contact as such.
Okay, thank you.
Yes, sir.
Thank you, sir.
Okay, if there are no further questions, thank you again for the application and the presentation, and I'll pass it on to Lars again.